Okay, we're going to be solving linear systems by substitution. They've given us two equations. And if you're looking for two variables, we have an x and a y, you need at least two equations to solve it. Okay? So we're going to number them. We'll call this equation 1, and we'll call this one equation 2. And we can choose either equation 1 or equation 2 to start with. And the goal will be to isolate for one of the two variables, either x and y. And it doesn't tactically matter. One of the variables will be easier to isolate for than the other, probably. So we can take a look. You tell me which equation you'd like to start with.
Okay, 3x plus 1.
Okay, so we'll start with equation 2. And which variable would you like to isolate for?
X.
X. Okay, so we'll do it in blue. Our goal is going to be to isolate for x. So we'll bring it down here. We have 3x plus 4y minus 16 is equal to 0. Okay, so the goal is to isolate for x, which means we essentially want everything else on the other side of the equation. Since x is on the left side, right? It's on the left side of the equation right now. We're going to take 4y and 16, and we're going to move them all over to the right. When we do this, because this is positive, the 4y at least, actually we'll do this one step at a time. Keep the positive 4y. When I move 16 to the other side, what will it become?
Negative 16.
Well, right now
No,
it's
if it's negative 16, now it would be positive.
Great. And what is 0 plus positive 16?
Positive 16.
Yeah, that's right. So instead of writing in 0 plus 16, we'll just put in 16, right? Next step, we're still trying to isolate for x. Let's move 4y to the other side. When I move 4y to the other side, what will it become?
Negative 4y.
That's right. So we have 16 minus 4y. And finally, we still got to isolate for this x here. So how do I get rid of that 3? What do I do? If I move that 3 to the other side, what does it become?
Negative 3.
Well, it's actually multiplication here.
Yeah, so it would be everything divided by 3.
That's right. So we have to divide. So we now have x by itself is equal to 16 over 4y divided by 3. Okay, everything like that. You can split it. You can have like 16 over 3 minus 4 over 3y. We'll just write it like this as one step. Okay. So now that we have this, we're going to take this information. Okay, this says x is equal to this, and we're going to plug it into the other equation for x. Okay, and I'll even highlight it so the note is a little easier. Highlight it in blue. Okay, so we're going to take blue might not be a good color. Oh, okay, okay. Okay, we can see it. I wasn't sure if we'd be able to see it. We're going to plug this in for the x in the other equation. Okay, so can we see it all on one screen? Yeah, we can. Okay, so our equation we have written in black. I'll rewrite it again. X minus 2y minus 2 equals 0. Okay, so let's take this info and replace our x with it. Okay, so now it becomes 16 minus 4 over y divided by 3. Okay, so that was the replacing of x. And then we write out the rest of the equation. Negative 2y minus 2 equals 0. Okay. Now, what we've done is there's only a y left in the equation, so we can actually solve for y. Okay, we just got to kind of simplify everything. So I'm going to get rid of these brackets. And again, the goal will be to simplify for y and isolate for it also. So let's write it out in black here. And what I'm going to do is I'm going to split this. I'm going to make this 16 over 3 minus 4 over 3y. Does this make sense to you, what I just did?
Yeah.
It's still the exact same thing from above. Okay. Minus 2y minus 2 equals 0. Okay. First of all, let's move all our constant terms, so non-variable terms, to the other side. So that would be the negative 2 and the 16 over 3. We'll take them both to the other side. Okay. When negative 2 goes to the other side, what will it become?
Positive 2.
Yep. And what about when I take 16 over 3 to the other side? What will it become?
Negative 16 over 3.
Yeah, so negative 16 over 3. I'll write it in red because those are the ones we moved. And plus 2, or positive 2. Okay. So let's start combining this. We can work in fractions. Do you prefer decimals or fractions?
Fractions.
You prefer fractions? Okay. I'm going to have to convert these values to fractions. Okay? Because in order to add and subtract fractions, our denominators need to be the same, correct? So since this is technically over 1, and this is technically over 1, what's the common denominator here? What do we need to change our denominator to?
1.
Well, this one's
Oh,
1.
sorry, 3.
Yeah, let's change it to 3. It'll be simple because we just got to multiply the top and the bottom of the fraction by 3. Correct?
Yes.
Okay. So when we do that, we have negative 4 over 3. What will negative 2 times 3 be?
Negative 6.
Yeah, negative 6 over 3y. Oh, sorry, and there should be a y attached to that. Did I lose it in the process? I did. There should be a y attached to that. Those are like terms. Can you see the negative there? Okay, and this will be minus 16 over 3 and plus 6 over 3. Perfect. Now, we know everything's going to be over 3. So we have to take negative 4y minus 6y. Do you know what that will become?
Positive 10 over 3y.
It won't be positive, it'll be negative, but it is 10 over 3y because they're both negatives, okay? So we have negative 10 over 3y is equal to, and when we combine negative 16 and 6, do you know what that will be?
Yeah, negative 10.
Yeah, negative 10. And it's over 3 again. Okay, it looks like these are the exact same thing. And here's the way we're going to simplify it. Sometimes you can do something to an entire equation. I want to get rid of our fractions. So I'm going to multiply the whole equation by 3. Okay, and what that's going to do is cancel out the 3's on the bottom. Okay, and if this was confusing to you, you could always just use your decimals, right, if the fractions weren't easy. And we'll have negative 10y is equal to negative 10. And then to isolate y, we've got to bring 10 to the other side. What do we do there?
So we minus negative 10.
Will we minus because it's
Or no,
multiplication?
it's not. We add, so y is 0.
Well, this is multiplication, negative 10 times y. What's the opposite of that?
Y.
Yeah, so we're going to divide by negative 10. So our y will be equal to the value of 1. Great. That's only one of the variables we've solved for. We've got y. We can now take this y value and plug it in either to equation 1 or equation 2 to solve for x. Which equation would you like to plug it into?
Equation 2.
Equation 2. Okay, so let me just copy it. I know you don't have the option to do this always. Take paste. Okay, here's our equation 2. Right? And we're going to replace y with the value of 1 since we found it. So now we'll end up with 3x plus 4 times 1 minus 16 is equal to 0. Okay, that 4 times 1 will become 4, and the goal will still be to isolate for x in this case, right? There's only one variable left. So let's get these two terms. 4 minus 16 is going to give us negative 12. So we get 3x minus 12 equals 0. I'm going to move negative 12 to the other side, so it becomes positive 12. So we get 3x is equal to 12. And then because this is multiplied by 3, to bring the 3 to the other side of the equation, we need to divide. So we end up with x is equal to 4. So now we found out that x is equal to 4 in this equation. Okay. So a lot of steps for substitution. If you get to the end and you're just not 100% sure if that worked, take your y and your x value and plug them into the two equations and make sure the equation is equal. Okay? And if it's equal, then that's your way of checking to see that you did it right.